Let's look at question 29. Here we have a bulb that's rated for 120 volts power supply. So when connected properly to a 120 volts power supply, the potential difference that occurs across the bulb is 120 volts. Okay? So when the charges flow through this bulb, they incur a potential drop of 120 volts, and this allows it to give its proper power rating. We're going to call this power P0. Now what happens if we combine two of these bulbs in series? Not in parallel, in series. So you should know by now that if I have these two bulbs in series, the potential difference across one of these bulbs is now half, because the voltage is shared by these two identical bulbs. So this would be 60 volts. The question asks, by how much would the power change from its original? We can call this P1. Okay? So we know a few formulas for power. In this case, we're going to use P equals to V squared over R. I'm going to say that each of these bulbs have a resistance of R. So to calculate P0 is 120 squared over R. It's fine to leave it in R. How about P1? In this case, you notice that the voltage has been halved, right? So it's half times 120 volts, the whole thing squared, divided by R. And this gives us 1/4 of 120 squared over R. So you can see here that P1 is 1/4 of the original value, 120 squared over R. Therefore, the change in the different power ratings is P1, or rather P0 minus P1 equals to 3/4 P0. And therefore there is a decrease by 75% in the power rating.